guys, we're on the back side of day 3 notes, and we just learned the quadratic formula on the front hand side, although you learned it back in algebra, so it should have been a review for us. And so in number 5, so these word problems are a little bit of our quadratic formula application. So there's a few keywords in these word problems that we have to pay attention to so we know what to set the equation equal to or what to plug into the equation. Okay, so number 5, it says that the height h in feet of a ball thrown upwards from a cliff at time t in seconds is given by this function. And so you are throwing a ball upwards from a cliff. Okay, when a ball goes upwards, it forms a parabola, okay, is what we have to remember. Okay? And the equation for that parabola is given. All right, so that makes it nice and easy. We don't have to come up with the equation. So part A is saying algebraically determine what the height of the ball is after 1 second. And so we have to remember that there's two variables in this equation. There's t, which stands for time, and then there's h of t, which is our height. Okay. When they say determine what the height of the ball is after 1 second, 1 second is our time, okay? And we're determining the height, which is what h of t is. Okay? So now that we have our variables, we can go ahead and plug in 1 for t. And so we'll say h of 1, or you can say just h of t. It doesn't matter. If you replace the t with a 1, it won't affect your answer. Okay, but on the other side, this t does need to get replaced with 1. And there's another t that needs to get replaced with 1. And we keep everything else. Okay? If we type that right into our calculator, just like we wrote it, out comes the number 20. And so we can go ahead and say 20 feet. That's the height of the ball after 1 second. Okay? And I don't know if that's the highest it goes or if that's on its way up or its way down. Okay, not quite sure how long it took for this ball here to go from throwing it up to coming down. Okay, maybe if we find out a little bit more information, then we could go ahead and figure that out. So in part B, it says algebraically determine the time at which the ball reaches its maximum height. Okay, well, the ball reaching its maximum height is right here. Okay, however, we have no idea where that is. So for instance, when I talk about which one of these do we know, we don't know the time. That's actually what they're trying to get us to solve for. And we don't know the maximum height either. And so a lot of people get tripped up on this type of equation. But really, you just want to figure out not the height of it yet. Okay, we want to know actually what time it reaches its maximum height, which would be down here. Okay, so if we think about it, that's right along what they call that axis of symmetry. And the axis of symmetry has a formula. It's x equals negative b over 2a. This formula, in fact, is a little bit of part of the quadratic, if you heard that, right? X equals negative b all over 2a. So that part of the quadratic formula actually figures out that middle height or that middle x value between the two endpoints there of your parabola. And so all we have to do is plug in. We just have to remember who is b and who is a. So coming back up here, we know a is our negative 16 and that our b is our 24. Okay? And so this formula becomes x equals negative b, which is 24, over 2 times a, and a is negative 16. Okay? Top is clean already, but the bottom cleans up to negative 32. The negatives are going to cancel, and 24 divided by 32 is 0.75. So it's going to take 0.75 seconds for that ball to reach its maximum height. Okay, so this would be like time 0 when you throw it, and now this would be 0.75. Okay, so now in part C, it says determine the maximum height that the ball reaches. Well, we know that it reaches that height, okay, when our time is 0.75. And now we can figure out what the height is that goes with that 0.75. So we're going to go back and we'll plug it in. Just like in part A, except that was at 1 second. And so now this is at 3/4 of a second. Okay, if we type it right into our calculator, just like we wrote it, we're going to figure out that 21 feet is actually the highest the ball reaches. Okay, so remember at 1 second they said 20 feet. So 1 second would be after our 0.75, so it'd be on the way down. So this right here is 1 second and 20 feet. Right? This point right here that we just found is 0.75 seconds and 21 feet. Okay, hopefully that makes sense. All right, let's take a look at part D. Now it says algebraically determine how long it will take for the ball to hit the ground to the nearest hundredth of a second. Okay? Anytime a problem says hit the ground, oops, okay? Hit the ground. What we have to know is when something hits the ground, the height now becomes 0. Okay, the height of the ball when it hits the ground now has a height of 0, right? Because it's right on the ground. Okay, so going back to our formula and talking about the only two variables in it, okay, we now know that the height is 0, so the h of t becomes 0, and we're trying to figure out how long it's going to take for that to happen. So we go back up to our original equation and we replace our h of t with a big 0, and everything else stays the same. Okay, because now we have to realize that we'll be solving for t, which if you remember, t is in the x spot, so we're really solving for x, okay? And we have a couple ways of solving for x, okay, or t in this case. We could try to factor it and solve it that way. We could try completing the square and solving it that way. Or now that we know our quadratic formula, we could use the quadratic formula and solve it that way, okay? So the options are open, all right? I cannot say that factoring will always work. The other thing why I won't try factoring is right here in the directions it says nearest hundredth. I already know I'm going to come up with irrational answers, and factoring only really works, 100% of the time on something that is nice rational answers. Okay, completing the square, that's a lot of steps to remember. Okay, and sometimes it can turn out a little messy. Okay, especially if one step goes wrong. I'm a big fan of the quadratic formula. I think it's a lot more user-friendly, and so I'm going to go ahead and use that. For the quadratic formula, we have to know our a, b's, and c's, and so I'm going to go ahead and say that a is negative 16. And that's the other thing about the quadratic formula, in it being more user-friendly, is that it doesn't matter what your leading coefficient is, if it's positive or negative. Okay, you just plug that number in. All right, so here we go, guys. X equals negative b plus or minus the square root, okay, of b squared minus 4 times a times c all over 2a. All right, so that's my first step always, is to plug in, and now my second step is to clean up. So this stays, square root stays, but it gets shorter, and we type in exactly what we wrote underneath, parentheses and everything. Okay, and when you hit enter, you should end up with 1,344 all over negative 32. Okay, that's the second step. Okay, now the third step is to simplify the radical and clean the radical up the rest of the way. Okay, so we can try to see if it's perfect by typing it in. Okay, or we can simplify it too. But what they're saying, guys, is that they want our answer to the nearest hundredth anyways. And so what I'm going to do is I'm actually going to go ahead and just type this in. In fact, I'm going to go ahead and erase that minus sign right here, because when I type it in, I want to type one answer in at a time. Okay, so I'm going to type in negative 24 plus the square root of 1,344, and then I'm going to hit the enter. Okay, and then I'm going to take what I get and divide it by negative 32, and then hit enter again. And now I can see that one of my answers, okay, is negative 0.39564 ... Okay. Now what I'm going to do is I'm going to type in my other answer. I'm going to type in negative 24 minus the square root of 1,344, and I'm going to hit the enter button. Then I'm going to divide it by negative 32 and hit the enter button again. Okay, and this time my answer is x equals 1.89 564 ... Okay, going back and remembering what I'm solving for time. Time can't be negative. And so I'm going to take my first answer and reject it. Okay. I'm going to keep my second answer, and they said to the nearest hundredth. So I'm going to underline the 9 and look next door. It's going to bump it up. And then now I can go ahead and say that my time, okay, is 1.90 seconds. And that's when the ball is going to hit the ground. Okay. All right. Let's try one more. Number 6. We have a rocket carrying fireworks is launched from a hill 80 feet above a lake. Okay. So the last one we were on a cliff. Okay. And this time we are on a hill. So either one, what was going to happen is our ball is going to start, it's going to go up, and it's going to come down. Okay. Just like the last one did. Except this one is a rocket. Okay. And it will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by this function. So very similar to our last one, okay, where time is t in seconds and h of t is the height. How long will the rocket be at or above 128 feet? How long will the rocket be at or above 128 feet? So the hill, remember, here is 80 feet, okay, when the rocket went off. And so eventually it's going to reach 128 on its way up, maybe go a little bit higher, and then reach 128 feet on its way down as well. Okay. And so what we're going to do is, because we want the height, or the h of t, to be 128, we are solving for the time. And there should be two values. There should be a t value here and a t value here. Okay. So we don't know the time, but we want the height to be 128. Again, over here, we don't know the time, but we want the height to be 128. Okay. All right. So we're going to go ahead and take h of t out and put in 128. Everything else stays the same. Okay. Remember, we can't do anything unless we are equal to 0. So I'm going to go ahead and subtract that 128. And we'll end up with negative 16t squared plus 64t, and 80 minus 128 is negative 48. And we are now equal to 0. Okay. Again, since we want to solve for t, which is really x, or what x equals, we could factor, we could complete the square, we could quadratic formula. I think that the quadratic formula is the most user-friendly, the one you guys make the least amount of mistakes on, the one that always kind of works for every equation that we have that's quadratic. So I'm going to go ahead and use that. And so we're going to go ahead and say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Now that we have that, we're going to go ahead and clean that up. And we're going to say x equals negative 64 plus or minus square root, but it gets smaller. We type it all in. 64 in parentheses squared minus 4 times negative 16 times negative 48 for a grand total of 1,024 all over negative 32. Okay. All right. Then what we're going to do is we're going to type this in just like we did in the last one. Okay, to figure out what x equals. So on this way, we're going to go ahead and type in x equals negative 64 plus the square root of 1024. Don't forget to hit enter. Then you're going to go ahead and hit divide by negative 32, and then you're going to hit enter again. And our x value is going to come out to equal 1. So what that tells me is I think this might have actually been factorable. Okay. Now we're going to type in our second answer. So x equals negative 64 minus the square root of 1024. 1024 must be a perfect square. All divided by negative 32. Okay. So remember, hit enter after you typed in the top, then hit divide by negative 32 and hit enter again. And this time x comes out to equal 3. So At 1 second, it reaches 128 feet, and then it keeps going up, turns around, and then hits 128 feet on its way down at 3 seconds. So in the problem, they wanted to know how long will the rocket be at or above 128 feet? Well, 3 minus 1 is for 2 seconds. For 2 seconds, it'll begin there at 128 feet. 2 seconds will go by, and it'll come back down and hit 128 feet. So kind of a different question, but we solved it. All right. I will see you guys on the next day of notes.